Hi, this is Tim, and today we're going to talk about syncing, sourcing, NPN, PNP, and how to determine what type of sensor you need for your PLC input. Before we get started, please take a moment to subscribe and tap the bell so you get notifications about our videos, and click that like button. It does a lot to keep us energized making these videos. And today's video is also going to show you the power of your comment to change the course of our videos. I posted this image over on Instagram, LinkedIn, and all the other social things, mainly just to tell you about a video that was coming up. And I couldn't believe the amount of conversation they ended up in those posts. Two in particular stuck out that really show the confusion over syncing and sourcing. Mike Reagan said source flows towards negative and sync was flow towards positive. And then another person named Aaron Kumar said source provides a path to plus, sync provides a path to minus. Now both of these guys are right. But when you put their answers side by side, you can see how you can quickly become confused by these terms. So the original intent of this video was to clear up syncing and sourcing using this basic template. One of my controls friends, Jeremy Ross, pointed out that syncing and sourcing is not always the same depending on your PLC manufacturer. And at first when he said this, I said, well, that is simply because one is talking about PLC inputs and the other is talking about the sensors connected to it. But when I got looking at it, I found out that he was correct. About 90% of major PLC manufacturers define syncing and sourcing one way, and about 10% of them define it the opposite way. Then one manufacturer really confused me because they define PLC outputs syncing and sourcing the way the 90% of the PLC market did, but their PLC inputs they defined the way the 10% did. So they flip-flopped. And finally, one manufacturer, and I'm not going to pick on anybody in particular, but halfway through the same user manual, they went from defining syncing and sourcing one way to the exact opposite way. But with that comment from Jeremy, this video quickly went from a basic this is syncing, this is sourcing type video to a much deeper video of here are how PLC input and output circuits work. And here is how to take the diagram from the PLC manual and figure out what sensor you need. So we're going to start off a really broad, this is syncing, this is sourcing, PNP, NPN, based off of that 90% crowd. But then I'm going to go through how exactly to look in your user manual and figure out exactly what type of sensor you need for your application. Two other notable comments. One was from Ronald Steed. He stated that these were often the source, no pun intended, of confusion in the industry. He gets kudos for helping us with our title. Also, one commenter pointed out that I had left my load and input out of my diagram, and that's why I couldn't figure it out. He was sure to tell me at the bottom of his comment that he was an electrical engineer. Guys, leave your credentials out of your comments, especially when you're making a Captain Obvious type comment, since they were left blank so that I could plug in the various different circuits. For this video, we are going to use an Allen Bradley 1769 L16 Compact Logix PLC and a 1769 L24 Compact Logix PLC. And the main reason is this PLC has strictly syncing inputs and sourcing outputs. And this one, the inputs and the outputs can be syncing or sourcing. So these are the two very common setups you'll see, no matter what PLC brand that you're looking at. So let's start with our basic circuit diagram. And here's our power supply, which has a plus and a minus. You can see I have a blank here, and it's going to go around, and I have another blank here. And for the majority of applications, one of your items will be syncing and one will be sourcing. Also, depending on your diagram, you may actually see this symbol here instead of this symbol. This is a battery symbol, but it's used very often on circuit diagrams. So both of these can be considered the same. Also, this is an AC circuit. We're not doing AC in this video. This is strictly about DC circuits. So going back to this, for the bulk of your applications, if you know one, you can figure the other out. In the case of our Compact Logic's PLC, the L16, it has syncing inputs. So in that case, if we put our PLC input here as syncing, then we need a sourcing sensor to go along with it. Now, if you're not quite following this, it's okay. We're going to go more in depth. We're going to actually pull up the diagram for this, and I'll show you how I figured it out exactly. Now, for the outputs, they are strictly sourcing. So we can do the same thing on our output, and we can plug in our PLC. Output is sourcing, so that means our load needs to be syncing. And we'll go through some details of exactly what that means. Now, in the case of the L24, it can actually go syncing or sourcing. So if we wanted our PLC inputs wired syncing, we can plug them in and we would know that we need a sourcing sensor. Whereas if we wanted our PLC inputs to be sourcing, then we would know we need a syncing sensor. Or the opposite is true also. Let's say you have an application and your sensor is already spec'd. Then if you had sourcing sensors, then you know you need to wire your PLC inputs as syncing. Or if you had syncing sensors, you would know you need to wire your PLC input as sourcing. But how do you actually wire things? So let's hit the easy one first, and that is your contact closure. So that would be your push buttons, your limit switches, even any sensor that has a normally open or normally closed contact that is completely isolated. And let's say that we're going to wire to our L24 and we're going to wire it sourcing. In that case, we have a PLC input that is sourcing. So our PLC input will have plus 24 on it, and it's going to feed 24 to our contact closure. And then on the other side of it, we're going to need to connect to the negative. Sourcing PLC input, you connect the PLC input to one contact and the minus of your power supply to the other. Whereas the L16, or if we were doing this one syncing, then it would look like this. So you would send power to your contact closure, which again is your push button, your limit switch, whatever. And then the other wire of it would go to your PLC input. And then usually through the common terminal, or in the case of the L16, which we'll look at closer in a second, it's called a field terminal, it would go on to the minus. So that's really easy. That's your contact closures. Where the issue starts to come in is when you have an actual sensor like this. So what is a syncing sensor and what is a sourcing sensor? The real basic answer is a PNP sensor is going to be a sourcing sensor. And an NPN sensor is going to be a syncing sensor. PNP is positive, negative, positive, and NPN is negative, positive, negative. But a guy taught me way long ago, actually he is a competitor of mine. There you go, competitors. Make sure that you help grow the next generation. He said to think of PNP as power and NPN as not power. And that's always stuck with me. So I know if I have a PNP sensor that is going to send power out or plus out, which is going to come on around to our PLC input and then on to our minus. And if I have an NPN sensor, it's going to be not power. So here we already have power, it's gone through our input, and we're going to come around and it's going to take it to our minus of our power supply. And we're going to go through these a little more detail in the wiring diagrams now. All right, so we're going to start by looking up the L24 just because it shows both ways you can wire it. It's a 1769 L24. Yeah, that's it. 21 manual. And all right. Okay, and this actually has, so this manual right here actually has both the L24 and the L16 in it. And let's just see if we can quickly find what we're looking for. Let's just look for the word sync. And okay, that's talking about the L16. All right, and here we are. So here are the L24's inputs. Here is a close-up of what we're looking at. So here is our DC in, and there's COM 0 and COM 1. And then here is our 16 outputs. And again, you have COM0 and COM1. So these are broken up into groups of 8. So you have 8 inputs that are 0 through 7 and another 8 that are 8 through 15. And they can be wired differently. So you can actually wire half of these syncing, half of them sourcing. And same down here, you could wire your outputs, half syncing, half sourcing. But so here's what we're looking at on that diagram. And right here, you can see here's that COM0. So this is that first group of 7. And here are the inputs connected to it. And depending on what you wire to each of these determines whether it's syncing or sourcing. So if we're going to use this as a syncing input, the same as we're actually using it over here on this L16, then we're going to want to put plus 24 volt to each of our sensors. And then the other side of our sensor is going to go to the PLC input. And then internally, all these are going to go around and they're going to come back to this common, or this COM0. And then since we wanted to be syncing, we're going to put this to the minus DC. Now, if you did want to do the sourcing, then you would simply do the opposite. You would feed the negative DC or the 0 volt of your power supply to each of your contact closures, and then the other side of those to the PLC inputs. And then internally, they would loop around a COM0, which would now be connected to the plus 24 volt of your power supply. Okay, and I just realized, and here's why it's great to look at the wiring diagrams to know for sure, is I told you that these could be syncing or sourcing on the outputs, but now that I look closer, they can't. So here, for the outputs, they are strictly sourcing outputs. So they're going to be sending 24 volt out. So here we have plus 24 volt going into the V plus terminal. And then COM0 is going to the minus 24 volt terminal. And then each output is going to go to its load with plus 24 volt. And the other side of your output is going to go back to the minus DC. So the inputs on it can be syncing or sourcing, but the outputs are strictly sourcing on this. Now for the L16, it is pretty much just the syncing side. So the L16, you're going to feed 24 volt to your switch, and then the other side of your switch is going to go to your input. And then in the L16's case, it has these field power connections, and it's FP plus, FP minus. And you just put plus 24 volt to the FP plus and minus 24 volt to the FP minus. But they do not have the option of switching. So in this case, you do have to make sure you have the right type of sensor. And that's going to be a sourcing sensor or a PNP sensor. About PNP and NPN, that's the one thing I don't think I've covered much of. PNP sensor, that's going to be power. Just remember, the P stands for power. So it's going to send plus 24 volt out. The NPN, no power. So it's going to sink power into it. So I think that pretty well covers how to wire the PLC. Then one question that we still have to address is what type of sensor do you need? Now for the 90% category, if it says that it is a syncing input, then you'll need a sourcing sensor. If it says it is a sourcing input, you'll need a syncing sensor. But if we go back and we look at this diagram, we can figure it out pretty fast even without that. So right here, if we feed plus 24 volt to our switch, and then we're going to our input, then we can kind of go back to our diagram. And plus 24 to our sensor, which could be that switch that they're showing there. It's going to go around. So we have a PLC syncing input, and we need a sourcing sensor. Oppositely, if we had negative going to our sensor, then we can look and okay, we have negative going to our sensor, and then we're going on to our PLC input. Then our sensor would be syncing. Now we know we need a sourcing or a syncing sensor. How does that equate to PNP and NPN? Very layman's terms here, a PNP you can think of as power. NPN, no power. So the PNP is going to send power out or be the source of power. So this would be a PNP situation. NPN, no power. So it's going to be on the minus side. So this syncing sensor would be an NPN. Now, another question I get a lot is, why do we have NPN, PNP versus syncing and sourcing? And I'll tell you the honest truth, I don't know. I just arbitrarily went and grabbed a sensor. So this is a sensor, just like we're talking about here. And it says source sync on it, which just seems to make so much sense to me, but some of them don't. Some of them use the terms NPN, PNP. And the other question that I do get a lot is, which is better, PNP or NPN, or which should I use? In the case of the L16, you're going to want to use PNP because it's the only thing that will work with this PLC. And that's probably the best way to think about it, is not which one's better, but which one fits your application. Beyond that, they're pretty much going to perform the same. There are people who argue that you shouldn't use NPN because if you short it to ground, it turns an input on, which could do something unsafe. There are people that argue against PNP because you could short it to ground and burn something up. And I'm going to stick with figure out what's good for your application. Now, there is one exception, and honestly, I didn't know enough about this to put it in a video. But I did see some claims, and it looks like it is true that I don't understand the electronics behind it, that NPN sensors can operate faster than PNP. And so that's why I think a lot of times you do see your high-speed applications more NPN. But that's I have no basis off of that, so I can't tell you for sure. Now, I think that about covers everything. Thank you to our patron supporters who did fund the making of this video. Also, thank you to Mike Reagans, Arun Kumar, Jeremy, everybody who turned this from a 2-minute video to what's probably a 25-minute video at this point. And again, your comments matter. So put any questions you have about this in the comments. Be sure to tell me what you'd like to see next. And again, I can't stress to you enough how much we appreciate you subscribing and liking our video. Also, YouTube thinks that you should watch this video next. And here's some similar videos we have on our channel. Till next time. Hi, this is Tim.
And this is Amber of TW Controls.
We run the automation store.
Be sure to subscribe for more great videos.
And like this video and comment on what you would like to see next.
Visit our website where we offer a full line of PLCs, simulators, control panels, PLC trainers, and more.